All right, IM3 classes. Today we're talking about the natural base E. E is a constant, kind of like pi. You guys know about pi. Um, it's 3.14159 on and on and on, doesn't end. So it's this big long decimal. E is the same idea. It's the same thing where it's a number, but it's a very long constant. Where we get E from is this expression here, the graph of this expression, 1 plus 1 over x all to the x power. That's this graph here. It's half the graph, actually, but it's this graph here. And it approaches the value e. So it has this limit of e. So you get more into why it works that way when you get into higher math classes like calculus. But for today, we're just going to be working with the number e. Most of its practical applications that you'll see in the real world is with compound interest, and we'll talk about those later on. But today, we're just going to be doing some basic problems with e. E is this big long decimal. We will round it for the purposes of today. We are going to say E is 2.1718. Right, that's what we'll be using for E. We're going to be graphing. We're going to need to do some calculations. This is what we're going to be using. Right. So simplify each expression. We are not going to multiply these out. This is just properties of exponents. This is kind of just like what we did last chapter. Remember, when you're multiplying with powers, you need to add the exponents. So e to the third times e to the sixth. You do 3 plus 6. That's going to be e to the ninth. And that's it. Again, just review what we did before. When you are subtracting with powers, when you are dividing with powers, you subtract the exponents. So you're going to have 5 minus 4 would be 1, so it would be e to the first. There's more e's on top than there are on bottom, so that e left over is going to be on top when you subtract. And then we do need to reduce this part here, 16 over 4. Better use is 4 over 1 or just 4. Again, 5 minus 4 is 1, so that's going to be e to the first, or just e. Either one is fine. This one here, we do have a little bit of invisible math you need to remember. So that's 3 to the first. And then these get distributed. So 3 to the first, 1 times 2 is 2. So that'd be, okay. That'll be 3 squared. And then e negative 4 times 2 is negative 8x. All right, here, 3 squared is 9, and you get e to the negative 8x. And normally we wouldn't want negative exponents. We're going to just deal with them. Negative exponents are going to be okay. All right. Next, so we have the powers, we have roots. What you need to remember about roots is roots are the same thing as half power. So is a fractional exponent rather. So I'm going to put that base, so 9e to the 6x. I'm going to change the square root to a 1/2 power. So remember, power's on the top, roots on the bottom. So here, I'm going to rewrite this whole thing like that. And then this is just like that last problem. This 9 has that invisible exponent of 1. And so I need to distribute the 1/2. So this is 9, 1 times 1/2 is just 1/2. 6 times 1/2, or half of 6, that's 3. So there'll be e to the 3x. We should simplify this. So again, 9 and 1/2, that's the same thing as the square root. So 1/2 is power is the same thing as square root. So this is the square root of 9, which is just 3. So it's 3 times e to the 3x. Similar thing here. I'm going to rewrite that power, put next there, as I'm going to rewrite the root as a power. The third root is the same thing as a 1/3 power. That 8 has an invisible exponent of 1. So this is going to get multiplied. 1 times 1/3 is 1/3. Then I have e 1/3 times 12. So 1/3 12, that's going to be 4x. All right, just multiplying those out. 1/3, so we can simplify this. So remember, this is third power, the same thing as the cube root or third root. Cube root of 8 is 2, e to the 4x. All right. Next thing we're going to do, oh, there's the assignment from the book. Next thing we're going to be doing is graphing it and then talking about if it's exponential growth or decay. So let's start off by graphing it. First thing you're going to do to graph it, we are going to use a table, right? We're going to make a table of values. I'm going to keep it simple for you guys. We only need to use 2 values. E is kind of weird to graph because it is not you're not going to get whole numbers from it. So we're just going to do 2 and make a curve best we can. It's going to be a rough sketch of it. The 2 values that you want to use for x that are going to make this the easiest. It's going to be 0 and, all right. So when x is 0, all right, I'm going to plug that in to the equation in for x. That 0 is going to replace this x here to figure out the y value. So 3 times e to the 0. Anything to the 0 power, and this is why we're choosing 0 here, anything to the 0 power is just 1. Right? 3 times 1 is 3. So when x is 0, y is 3. Right? I'm going to do the same thing for x equals 1. Again, that 1 is going to go into the equation. That's not what I wanted. That's going to go into the equation for x here. So you get 3 times e to the first. What we're going to do for e, again, I'm going to show you on the calculator. There is an e button, and then you got to use the exponent. It's just going to be easier to show in person, so I can show you know, I see the buttons here. When we're in class, I'll show you this. Right now, if you're doing this at home, what you can do is just use 2.718 as e. So anything to the first power is just itself. So I'm going to change the e to the first. That's 2.718. And then multiply that out. So 3 times 2.718 is 8.154. So this is why the graph is going to be weird. You just kind of have to approximate where that point's going to be. This first one's easy. X is 3, y is 0. So that point's going to be here. And then 1, 8 point, I don't have, it's going to be like right here. Right. And then I'm going to connect these dots. It's going to come through like this. All right. So with it, because you're not going to get negative exponents. So our graphs are always going to have an asymptote at the x-axis, or I shouldn't say always the x-axis. They could be down or so. Wait, no. When you put in negative values for x, you're still going to get, because it's an exponent, you're still going to get a positive graph like this. So it's going to look up like this. When your graph is going, it's increasing from left to right. It's shooting up here. This is an exponential growth. Exponential growth. All right. And that's as accurate. Why does my point keep disappearing? Stop disappearing. We're going to disappear. You see? There we go. All right. It's exponential growth. All right. Let's move on. The next one. So e to the negative 0.5x. Oh, fun. So what we're going to do, again, it's going to be our same x and y. Keep it simple. It's going to be 0 and 1. All right. So x equals 0. Again, that's going to find the y value. That's going to go in to the x in the equation. So that's going to go right there. So I'm going to get e to the negative 0.5 to the 0. Negative 0.5 to the 0 is just 0. Anything 0 power is just 1. Next one, x to the x is equal to 1. So it's going to be y is equal to e to the negative 0.5x. The 1 is going to go in for x. So you're going to get negative 0.5 to the first. That's going to be negative 0.5. E to the negative 0.5, you're going to put that in a calculator. So I'm going to do 2.718 for E. And then use my exponent button, negative 0.5. That comes out to 0.606 dot, 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 dot. So about 2/3. All right, I'm going to plot these points. So 0, 1. Why does this stupid, hmm, hmm, great. 1 about 2/3, so that's going to be lower here. That's not quite 2/3. This is just really bad today. Thank you for, oh my. So I can't like, I gotta turn off like the shortcuts. I don't know how to do that. Anyway, but you see how this is coming down here? So it's gonna be coming down this way. All right. So it's gonna look something like that. So as it's going down and approaches 0 here, this is going to be an exponential decay. Right. And so I think that'll do it. So what you want to do is, again, just for the x, just use 0 and 1. So we're just going to keep it simple. Sketch your graph best you can, and figure out if it's exponential growth or decay, if it's going, up or down like that. So that'll do it. We'll see you next time when we start getting into logs.